This setup features our 300 series PLC and inverter with PROFIBUS communication, and our hardware includes a PLC and a small motor. All the terminals below the inverter are connected to the terminals on the PLC corresponding to these signals above. Each of our terminals matches up one-to-one, so there's no need to worry about not finding the right connection. These are the button signals and indicator light signals. Now let's take a look at this part. This section includes the power supply switch, the power supply module, and the terminals for 24-volt power supply. Above are our 16 indicator lights. And because this PLC has 6 analog channels, we designed 2 at the very beginning. There are 2 analog current inputs, 2 analog voltage outputs, 1 analog current output, and 1 analog voltage output. Below that are our indicator lights and buttons. There are 4 here. 2 are selector switches and 2 are 3-position selector switches. All the rest are our indicator lights. Additionally, this is our emergency stop button. After pressing the emergency stop, the entire control circuit will lose power. This is our power switch. When you press the power switch, all control points will be powered. Our power supply uses an external 3-prong socket with a ground wire. Now we turn on the selector switch, and at this moment the indicator light comes on. The entire panel folds down. Now let's demonstrate the indicator lights and buttons. Are there any faults with them? Turn it on. With the first knob, all the indicator lights are normal, which means the indicator lights are in a normal state. Reset all the indicator lights. Next, let's test the running light. At this time, the running light operates at an interval of 1 second per cycle. Finally, let's test all the inputs. Press this button. PC input to the terminal. We will test them one by one. How many meters did the test reach? Next is our PLC controlling the frequency converter via PROFIBUS communication and then testing the motor control. Now we will perform a jog test. Turn it to the left, and at this moment the motor rotates forward. Turn the knob to the right, and now the motor stops and starts to reverse. Now let's test. The motor operates at a certain frequency. After pressing this switch, observe that the frequency converter now displays 52. Press this button to input 25 Hz. Press this button again. Input control. But if you press this button, it inputs negative 25 Hz, and at this point the motor will reverse. Additionally, all control settings can be customized by our clients. Here we are only demonstrating the effect. Finally, let's test the motor stop button. After turning the knob down, the motor will stop. The motor stop demonstration is now complete.